Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. I am Sudhir MK. In this class, I am going to discuss about competitive questions from sets topic, and this is competitive class 2. Please subscribe the channel for more video notification. Now first we discuss some operation on sets. So that is, first it is difference of sets. So let A and B be two sets, then A minus B. So it is the set of those elements of set A which are not in set B. So A minus B means you have to write all the elements which are present in A but it is not in B. So we consider one example. So if A equal to 1, 3, 5, 7, 8 and B equal to 3, 4, 5, 6. So what you do is you have to write all the elements of A only but it should not present in B. So you consider here 3 is present in A and B and 5 is also present in A and B. If you want to find A minus B, so you have to write remaining element, that is 1, 7, 8. So that is, we should write elements of A but it should not be present in B. And if you want to find B minus A, you have to write all the elements of B, so which are not present in A, that is 4 and 6 only. So here common element you should not write. So A minus B and B minus A. That is called difference of sets. So next it is complement of a set. So let U be the universal set. Universal set means it is a big set which contains all the elements of other set. It's a big set which contains all the elements. So let U be the universal set and A be any set. So here A is subset of U. So then complement of set A is the set of all those elements of U which are not in the set A. So that is, the complement of a set means you have to write other elements which are not present in A. So it is denoted by A dash or it is AC. So that is A dash equal to U minus A. That is, you have to write all the elements of universal set which are not in A. So that is other than A. So it is set of all X such that X belongs to U and X does not belongs to A. So we consider one example. So let U equal to 1, 2, 3 up to 8 and A equal to 1, 3, 4, 8. So here A set is 1, 3, 4, 8 and A dash. If you want to find A dash, we have to subtract these elements from the universal set. That is, you should not write 1, 3, 4, 8. So other elements are 2, 5, 6 and 7. So that is A dash. So A dash is other than 1, 3, 4, 8 which are present in universal set. It is 2, 5, 6 and 7. So next it is union of sets. Let A and B be two sets. Then union of set A and B. So this is symbol for union and it is set of all those elements which are either in A or in B or in both. So here we have to write all the elements from A and B. Here we have to write all the elements which are present in A, which are present in B or which are present in both. So that is union. Union means you have to take all the elements from A and B. So next it is intersection of sets. So let A and B be two sets. Then intersection of A and B, it's denoted by A intersection B. This is symbol for intersection. Is a set of those elements which belongs to both A and B. Here important, A intersection B means we have to write all the elements which belongs to both A and B. So we consider one example. Let A equal to 1, 3, 5, 6 and B equal to 1, 2, 6, 9. So then what is A union B? So here we have to write all the elements. That is, we have to write 1, 2, 3, 5, 6 and 9. So here we have to write all the elements. It is 1, 2, 3, 5, 6, 9. So then what is A intersection B? We have to write only common element. So here 1 is present in set A and 1 is present in set B also. So same type, 6 is present in set A, also 6 is present in set B. So that is 1 and 6 are common element. It present in both the set. So therefore A intersection B means it is set of common elements, that is 1 and 6. So here A union B is 1, 2, 3, 5, 6, 9. That is, you have to write all the elements. And A intersection B means it is 1 and 6. We have to write common elements which are present in both sets. So next we discuss one problem. It is problem number 15. If An equal to set of all Ax such that X belongs to N. So it is set of natural numbers. Then what is 3n intersection 7n? Here An means it is set of all Ax. Ax means you have to multiply A with natural numbers. So it is multiples of A. That is A into 1, A into 2, A into 3 like that. So then what is 3n intersection 7n? So first we find 3n. So 3n means it is multiple of 3. 3 into 1 is 3, 3 into 2 is 6, etc. So then what is 7n? 7n means it is multiples of 7. It is 7, 14, 21, etc. So now we have to find intersection. So that is common element which are present in both the sets. Now here we can see that when we continue, we get multiples of 3 and here we get multiples of 7. So here common elements. So common elements are, it is multiples of LCM of 3 and 7. It is 21. So here we get 21, 42, etc. These are common elements in given two sets. So therefore it is 21, 42, etc. which are multiples of 21. So therefore intersection we can write it as multiples of 21. It is same as 21n So therefore it is same as option A. So therefore option A 21n is intersection of 3n and 7n. So next we study disjoint sets. So two sets are said to be disjoint if and only if they have no common element. So if there is no common element in two sets, then they are called as disjoint sets. Here A intersection B should be empty set. That is, there is no common element in A and B. So for disjoint sets, we get A intersection B is empty set. So next some results. So fundamental results. First one is identity law. So that is A union empty set is always equal to A. So when we take union, always we get big set. So therefore A union empty set is always A, and A intersection empty set is empty set. When we take intersection, always we get smaller set. So here empty set is smaller set. So therefore A intersection empty set is empty set. So second one, idempotent law. So it is A union A is A only, and A intersection A is A only. So it is A union A is A, and A intersection A is also A. So next it is U union A equal to U. That is, when we take union of universal set and A, so we get universal set. Here U is the bigger set. So therefore when we take union, always you will get bigger set. So next it is U intersection A. It is A only. So when we take intersection, always we get smaller set. So here A is the smaller set. Therefore we get A only. So next it is U dash. That is complement of universal set is empty set. And empty set dash, that is complement of empty set is universal set. That is U dash means it is U minus U, which is empty set, and empty set dash means it is U minus empty set, which is same as U. So next it is A dash whole dash. If we take 2 times complement, we get same set. So therefore A dash whole dash is A only. So next it is A union A dash. When we take union of A and its complement, always you will get universal set. So it is A union A dash is universal set, and A intersection A dash is empty set. So A dash means other than A. A means given set. In A and A dash, there is no common element. So therefore, we get A intersection A dash is always empty set. So next it is De Morgan's law. So A union B whole dash equal to A dash intersection B dash. So it is important. A union B whole dash equal to A dash intersection B dash, and A intersection B whole dash is A dash union B dash. So these two laws are called as De Morgan's law. So next we discuss question number 16. Let n of A equal to 3 and n of B equal to 6, and A is a subset of B. So then what is n of A intersection B? Now here important, A is a subset of B. We have to consider set A with 3 elements and set B with 6 elements, and A is a subset of B. So then what is n of A intersection B? If you want, you can take example, or else directly also you can write. Since A is a subset of B, when we take intersection, always we get smaller set. So total number of element in the smaller set is 3 only. So therefore option A is correct. So, or else we take one example. So take A equal to 1, 2, 3 and B equal to 1, 2, 3, 4, 5, 6. Now here A intersection B is 1, 2, 3, which contains only 3 elements. So therefore n of A intersection B is 3. So that is option A. So here option A is correct option. So next question, question number 17. The set A intersection B dash whole dash union B intersection C is equal to. So here we have to find A intersection B dash whole dash union B intersection C. Now here it is A intersection B dash whole dash union B intersection C we have to find. Now here we can use De Morgan's law. A intersection B dash whole dash is A dash, in place of intersection you have to write union. It is A dash union B dash whole dash. So but B dash whole dash is B only, and union B intersection C as it is. Now compare these two sets. So here we have A dash union B, and here we have B intersection C. Now here we have common element from B and C. Now here we have all the B elements, and also we have elements of A dash. So therefore when we compare these two, so it is A dash union B is bigger set. So this is bigger set compared to B intersection C. So when we take union of these two sets, always we get bigger set, which is A dash union B. Since here A intersection B is a subset of A dash union B, so A dash union B union B intersection C is A dash union B only. So which is option B. So here correct option is option B. It is A dash union B. Here A dash union B is a bigger set and B intersection C is a subset of A dash union B. So therefore when we take union, always you will get bigger set, which is A dash union B. So next question, it is question number 18. If AB intersection CD is not equal to empty set and BC intersection AD is empty set, then ABCD is whether it is a quadrilateral or it is a parallelogram or it is a rhombus or it is a trapezium. Now here ABC, it should be some shape. Now here what is given? AB intersection CD is not empty. Now here AB and CD are two sides. So AB and CD are two sides. So it is AB and another side is CD. If two sides are parallel, so then they will not intersect. If they intersect, so we have one common point. So therefore, here AB intersection CD is not equal to empty set, means they are not parallel. So we can consider like this. So here AB and CD, they are not parallel. So AB and CD, they are not parallel. But BC intersection AD is empty set. That is BC and AD, they are parallel. BC and AD, it is parallel. Therefore, we get shape like this. So here AB and CD not parallel, but AD and BC are parallel. So since two sides are parallel, this is a trapezium, which is option D. So here two sides are parallel, so therefore their intersection is empty set. If two sides are not parallel, they will meet at a point, so then their intersection is not empty set. Therefore in this figure, two sides are parallel, so therefore it is a trapezium, which is option D. So next question, let the set S equal to 1, 2, 3 up to 12 is to be partitioned into three sets A, B and C of equal size. So thus A union B union C equal to S, A intersection B equal to B intersection C equal to A intersection C equal to empty set. The number of ways to partition of S is. Now here given one set S, which is 1, 2, 3 up to 12. You have to divide this set into three sets. So A, B, C of equal size. That is, they should contain equal number of elements. That is 12 by 3 is 4. That is, A should contain 4 elements. So we can consider like this: 1, 2, 3, 4. And B should contain 4 elements. It may be 5, 6, 7, 8. And C should contain other 4 elements. That is 9, 10, 11, 12. So this is one partition. So like this, we can find one partition. So here A, B, C are three sets of equal size. And A intersection B. So one more condition. So there should not be common element in these three sets. That is A intersection B is empty set. B intersection C is one empty set, and C intersection A is also empty set. So this type of set is called as partition of S. Now we can form in other way also. So we can take A equal to 2, 3, 4, 5, and we can take B equal to 6, 7, 8, 9, and we can write C equal to 10, 11, 12 and 1 here. So this is one more partition. So like this, different partition we can form. So now here question is how many partition we can form. Now here we have to form three partition. It is A, B and C. Each contains 4 elements. That is, they should be equal in size, means each should contain only 4 elements. Now here we have to form one set with 4 elements. So that is selection. We have to select 4 elements from 12 elements. We know that selection is combination. That is, first set can be formed in 12C 4 ways. So that is, there are 12 elements. To form set A, we have to select 4 elements. So therefore, it can be formed in 12C 4 element. So remaining elements are 8. So after forming set A, so remaining elements are 8. We have to form set B from these 8 elements. So that it can be formed in 8C 4 ways. After forming set A, 8 elements are remaining, and we have to select 4 elements from the remaining 4 elements, and we can form set in 8C 4 ways. After forming set A and set B, so again 4 elements are remaining. So we have to form set C from these elements, and we can form in 4C 4 ways. So this is set A, and this is set B, and this is set C. So set A can be formed in 12C 4 ways, and set B can be formed in 8C 4 ways, and set C can be formed in 4C 4 ways. So here one event can be done in 12C 4 ways, another event can be done in 8C 4 ways, and third event can be done in 4C 4 ways. So together we can form in 12C 4 into 8C 4 into 4C 4 ways. So here we can use formula. We have formula NCR. NCR equal to N factorial divided by N minus R factorial into R factorial. So therefore here 12C4. So 12C4 is 12 factorial divided by 12 minus 4 is 8 factorial and into 4 factorial. So like this we can use formula. So 12C4 is 12 factorial divided by 12 minus 4 is 8 factorial into 4 factorial. So next it is 8C4. So 8C4 is 8 factorial divided by 8 minus 4. It is 4 factorial into 4 factorial into 4C4. So 4C4 is 1, or you can write it as 4 factorial divided by 4 minus 4. It is 0 factorial into 4 factorial. So here 4 factorial cancel, 8 factorial cancel, remaining is 12 factorial divided by 4 factorial whole cube, which is option B. So here correct option is option B. Now here we have to consider it as 3 different events. So therefore here it is multiplication. It is 12C4 into 8C4 into 4C4. So therefore total number of partition is 12C4 into 8C4 into 4C4. That is 12 factorial divided by 4 factorial whole cube, which is option B. So here correct option is option B, which is 12 factorial divided by 4 factorial whole cube. So next question number 20. If A1, A2, A3 up to A30 are 30 sets with 5 elements each. B1, B2, B3 up to Bn are n sets with 3 elements each. And union of AI, I equal to 1 to 30 equal to union of Bj. So j equal to 1 to n is same as S. And each element of S belongs to exactly 10 AIs and exactly 9 of Bjs. So then n equal to, here problem look like some complicated problem, but it is very easy problem. So now here it is given A1, A2, A3 up to A30 are 30 sets with 5 elements each. I will give one example. So I will consider some sets. So it is 1, 2, 3, 4. So I will consider set A equal to 1, 2, 3, 4, A1. So then A2. So I will consider A2 as 3, 4, 5, 6. So then I will consider A3. So A3 as it is 5, 6. Then I will consider it as 1 and 2. So now like this we have A1, A2, A3 up to A30. So that is there are 30 sets with 5 elements each. So here I took only 4 elements, but actually they have 5 elements. So then B1, B2, B3 up to Bn. So there are n sets. In B series we have n sets. So with 3 elements. In set B1, B2, B3 there are only 3 elements. It is given that union of AI, that is A1, union A2, union A3 all are equal to S. So same type union of Bj, it is B1 union B2 union B3, it is same as S only. That implies total number of elements in union of AI also equal to total number of elements in union of Bj. So here total elements in union of AI is same as total elements in union of Bj. It is same as total element in the set S. Now how to find total elements? So here we have 3 sets. So here A1, A2, A3 are 3 sets and we have 4 elements each. So that is there are 3 sets and 4 elements each, but I am not using 4 3s are 12 elements. So here I am using only 1, 2, 3, 4, 5, 6. That is only 6 elements. Now how I will get that 6? So here each element. So suppose you consider 1. So 1 is repeated in 2 sets. And 2 is repeated in 2 sets. And 3 is repeated in 2 sets. 4 is also repeated in 2 sets. 5 is repeated 2 sets. And 6 is also repeated in 2 sets. So like this, it is given that all the elements of A are repeated in exactly 10 sets. That is, each element is repeated in 10 sets. And each element of Bi, it is repeated in 9 sets. Like this, each element is repeated in some set. So here each element is repeated in 2 sets. So therefore, I will divide it by 2. So therefore, total number of elements is 3 into 4 divided by 2. So I will get 6. So here to calculate total element, we have to multiply total number of set into total number of element divided by number of sets where the elements are repeated. Here you have to divide by number of sets in which the elements are repeated. So when we consider set AI, that is A1, A2, A3, etc. So there are totally 30 sets. So totally there are 30 sets. So we get 30 into 5. That is in set A we have 5 elements and each element is repeated in 10 sets. Therefore total number is 30 into 5 divided by 10. So whereas we consider series Bj, that is there are n sets. So there are n sets and each set contains only 3 elements. So total number of element is n into 3 divided by 9. So that is each element is repeated in 9 sets. So therefore here we get 30 into 5 divided by 10. This is for A series equal to n into 3 divided by 9. So this is for B series. But union of A and union of B is same set S. So therefore total number should be same here. So therefore 30 into 5 divided by 10 equal to n into 3 divided by 9. So here we can cancel this and here we cancel 3. So remaining is 5 equal to n divided by 9. So therefore n equal to 45. Which is option D. Here we calculate total element. So total element is number of sets into number of elements divided by number of sets where element is repeated. When we calculate this, we get n equal to 45. So which is option D. So next it is symmetric difference of set. Now we see what is symmetric difference. Let A and B are 2 sets, then their symmetric difference is the union of set A minus B and B minus A. So here you have to take union of A minus B and B minus A. And it is denoted by A delta B. A delta B means it is A minus B union B minus A. So A delta B means it is A minus B union B minus A. So you have to find A minus B and B minus A. Then we have to take union of these 2 sets. It is called as symmetric difference and it's denoted by A delta B. A delta B is a set of all x such that x belongs to A minus B or x belongs to B minus A. So or means we have to take union. So next we discuss one problem. It is problem number 21. So let A equal to set of all x such that x square equal to 1 and B equal to minus 1, 1, 2, minus 2. Then what is A delta B? So here we have to find symmetric difference. First we find set A, then we find A minus B. Also we have to find B minus A, then we find A minus B union B minus A. Now here it is given x square equal to 1. In set A it is given x square equal to 1. So when we solve this we get x equal to plus or minus 1. So therefore A equal to plus or minus 1. And B is already given, it is minus 1, 1, 2, minus 2. Now first we find A minus B and B minus A. Now A minus B from A, so you have to subtract minus 1, 1, 2, minus 2. That is common element you have to subtract. So that is 1 minus 1 is common element. When we subtract this, no element is remaining. So therefore we get empty set. So A minus B is empty set. So then we find B minus A. So from B we have to subtract common elements. When we subtract common elements, remaining is 2 and minus 2. So it is A minus B is empty set and B minus A is 2 minus 2. So then we have to take union. So union of empty set and 2 minus 2 is 2 minus 2 only. So which is option D. So here correct option is option D. So here A delta B is 2 minus 2, which is option D. So first find A minus B, then find B minus A, then take union. That is A delta B is A minus B union B minus A, which is 2 minus 2. Here it is option D. That's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.